Hello, and welcome to a hands-on intro to Docker for testers. My name is Gene Gotimer, and I will be your host for this workshop. To get started, you're going to need to set up a an Ubuntu box that you can use to follow along. You could do all these on a Windows box or Mac if you have Docker set up already on it. If you're doing this as part of one of our workshops or our tutorials at conferences, then I probably already provided you with a box that you can SSH into that has all this set up for you. But if you're doing it on your own, here's what you'll need installed. You'll need Docker installed. You'll need Docker Compose installed. You'll need the Redis CLI installed, the command line interface. You'll need to have access to Docker, and that usually means being part of the Docker group. And there's actually a script I use. I start with an Ubuntu Bionic image on AWS, and then I run the script that's available at the URL you see there. That's just a gist that shows you the commands you can run. So you can go ahead and set up your own box. But like I said, if you're doing this as part of one of our tutorials, then we've already set that up for you. So let's go ahead and get started. We'll talk a little bit about the workshop. We'll talk a little bit about how Docker is used, and then we'll get right into the hands-on pieces, and you can follow along. All right. So first off, I work for a company called Coveros. Coveros is a consulting company. Most of us live outside the Washington, D.C. area. That's where I am in Northern Virginia. We help organizations build better software faster and more reliably, and we do that using Agile. We have a lot of different services. We focus a lot on DevOps and Agile. We do a lot of DevSecOps, transformations. We do development. We also spend some time doing training, but we are really practitioners. That's where the training comes in from, is from our experiences. We have a lot of different commercial clients, and big companies, small companies, and because we're outside of the Washington, D.C. area, of course, we do a lot of federal government work as well. I happen to right now be on a project with the Department of Homeland Security. All right, so the course is called A Hands-On Intro to Docker for Testers. So let's talk about containers, right? Docker is a container technology, so let's talk about what they're for. To start with, most of us nowadays are familiar with virtualization, where it's one physical system simulates multiple virtual systems. So you share the CPU, you share the memory, the networking, you share the hard drive and the peripherals, and you just kind of pretend they're all split into separate VMs, separate virtual machines. Okay? Containers is a similar idea, but what we do, we have our hardware, our infrastructure, right? On top of that, usually we have a hypervisor, maybe an operating system and a hypervisor, but the hypervisor is a piece of software that lets us pretend that we have multiple virtual machines on that system. And each of the virtual machines is self-contained, right? It has its own operating system. It has whatever apps we're running on them. So you can set up several of them and let them share the resources. Well, containers works a little bit different. Containers, you still have an infrastructure. You do have an operating system on the host, usually. Sometimes that can be very thin, but maybe it's a regular operating system like Windows or Linux. In our workshop here, we'll be using Ubuntu Linux. And then on top of it, you have the Docker application, right? And what Docker will do is just provide you an interface to the host operating system for each of the applications. So then the applications can run, and you're not having each virtual machine, in this case, each container, running its own operating system. They're all sharing the host operating system. That lets you get much heavier density, much tighter many more boxes on one, or containers rather, on one system than you could do VMs, right? And they'll also start up faster. And we'll talk a little bit more about why that is in just a second. So, where should we use containers? Well, as testers or in software development in general, we use it in a lot of different places, right? We might use it for our build infrastructure. This is one of the great places to get started with containers. Jenkins, those of you that use Jenkins as a continuous integration service, um, rather than standing up slaves to build on that are virtual machines, you can have slaves that are fresh Docker images. So every time you go to build, you're building on a brand new, clean system, right? It's a Docker container rather than a whole new VM, right? So you don't have stuff left over behind. It's always clean. It's usually parallelized because that way we can spin up if 10 people check in all at once and want to do 10 builds at once. You don't have to have 10 virtual machines sitting out there as Jenkins slaves. You can spin up 10 containers. They spin up quickly. You use them, and when they're done, you dump them. There's even a distribution of Jenkins called Jenkins X, as they put it. It's an opinionated way to do continuous delivery with Kubernetes. Kubernetes is an orchestration layer on top of Docker. So build infrastructure is one place we find a lot of people start out using it. Another great place, especially for testers, to use Docker is in setting up a Selenium grid. If you use Selenium to do your functional testing, right, it's remote browser control. The Selenium grid, and we'll actually do this in the workshop, is a way to spin up a bunch of different browsers in Docker containers, different combinations of browser, VM or operating system, maybe versions of browsers, do all your testing, spin them back down when you're done. You can have them done in parallel, so you can run a lot of different tests all at once. And again, you don't need to run 10 different sets of functional tests at once. You don't need to have 10 different virtual machines, each with the browser installed. You can spin up 10 different containers. And that means you can do a much wider breadth of testing all at once, which can really cut down your test times for automated functional testing using Selenium, for instance. Another place, and this is getting more towards where a lot of organizations look to use Docker, and that's deployment. Another place you can use it, right? The system under test as testers will always be a fresh system if we can spin up a Docker container to do our testing on. There's no garbage built up from previous deploys. Every time we deploy it fresh. Everyone can have their own. You can create them on demand. You don't have to have this shared box that you have to reserve time on or worry if someone else is doing something on it or doing something destructive on it. The target system that you have is always going to be a fresh system that looks exactly like the system that you're going to deploy to production, which leads us to the next piece, which is called immutable, right? Systems using Docker, when we use Docker images and we carry those Docker images through our pipeline, through our build process, we install and configure them on the Docker container, and then we move that Docker container through. So in every environment, we are using the same installed system. There's no installation configuration to do. We've only had to deploy it once, and then we just move that Docker container and use that wherever we need, or the Docker image, and we spin up a container that's an exact duplicate. It doesn't need to be reconfigured. So what is tested is exactly what was deployed, and it gets you out of this idea of works on my machine. Geez, it worked in that last environment. It worked on the developer's machine. No, in this case, we're going to pass that whole machine through that Docker image, and everyone's going to get a chance to use it the same way. And we're definitely going to do that through this workshop. Another great part of Docker containers is that they're very scalable. Because they're immutable, in other words, they can't be changed once they're deployed once, or once we set them up once, we cut that image. They can be cloned because there's nothing different about them. They are all identical. That also means that we can set them up so that if we are, say, hosting a website on them, and we want to be able to allow for a sudden influx of customers, right, visitors to our website, we can go ahead and spin up as many as we need as people come in, right? And then when they're done, we spin them back down, right? They're very quick to spin up, very quick to spin back down. It keeps our costs low. It means we can handle sudden spikes in traffic, and we don't have any problems with having to keep some reserved instances spun up ahead of time that will take 2 or 3 minutes. We have to precede whatever traffic we were going to get. All right. And one other place that's really, really nice for Docker, especially as developers and testers, is experimentation. Because you can spin things up so quickly, install something, spin it back down when you're done. You can do destructive testing. You can play around with something. And if you mess it up, hey, just blow it away, spin up the image again. You're right back to where you started. So Docker tends to be a really good place to do experimentation, whether you're looking at new tools, different versions of tools or software, looking at new techniques or playing around with new configurations. All of that type of stuff can be done in a Docker container and is very, very quick, as we're going to see. All right, just before we get started with our hands-on piece, let's go through some basics for Docker. Uh, First off, I've already been talking about Docker as if you knew about it, but it is containerization software. It's not the only type of containerization out there. There are other options, but certainly Docker is the one most of us think of when we talk about containerization. Docker is free and open source. It runs easily on Windows, Mac, Linux. It's very, very easy to install. And it works really well in a lot of the cloud offerings, whether you're working on AWS or Amazon Web Services, Microsoft Azure, or Google Cloud. It's very easy to get up and started with Docker. All those cloud services actually have Docker services native too. You don't even need to spin up your own VM if that's the way you want to handle it. The value to us as testers of using Docker and Tester, I already mentioned, no more works on my machine, and its near cousin, you must have configured it wrong when it doesn't work on the machine, right? Because we're going to do that deploying configuration once and pass that whole image along. Docker allows the same binary to be deployed to different environments because we're just going to move this image through, which makes it very easy to set up deployments for testing, right? As we're going to see, spinning up a Docker container is something that can be done the same way over and over and over. And you learn it once, don't have to figure it out for different applications, different containers, different images. It gives us disposable test environments. We can go ahead, do our testing, blow it away when we're done. If we're doing destructive testing, we don't have to worry about the effects of a destructive test, or of the effect of a destructive test on later tests in our test session. We can do different browser versions, emulators and containers, all of that. Plus, the ability to stand up multiple environments quickly means we can run multiple tests or multiple sets of tests or multiple banks of tests in parallel. We can have multiple testers all doing their own work without stepping on each other's toes, even if they're testing the same application. Right? Okay. Now, some pieces that make Docker very useful that we're going to see as we go through this workshop are first, layers. When we set up a Docker container, what we do is we use something called a Docker file that we're going to play with, and each Docker file, each single instruction in a Docker file creates a layer, and that layer is immutable. It's read-only. It can't change. And then on top of that, whatever the next command is, the next layer we throw on top of it, that's also immutable, and that's only the differences from the layer before it. What happens this way is, since they're immutable, they can't be changed, they're read-only, we can spin up similar containers. Maybe the whole thing's the same, maybe they're just based on the same OS, maybe they're similar applications, and we'll play around with some of this and we'll be able to see it, that share different layers. Those layers, because they can't be changed, they're only kept in memory once. So it's not just that the containers are smaller than VMs, so we can spin up more VMs or more containers than we could VMs on a box, but even the container images themselves, if they share different layers, we don't even need to, they are sharing that thing in memory and on disk, right? So we don't have to worry about multiple copies. If we want to spin up 10 instances of the same app, all of those layers are the same. It does not take any extra space except for the container layer, the thin read-write layer that's thrown on the top to hold any instance data, anything that's happening in flight, the stuff that's actually changing. But that's very, very small. So we can spin up a whole lot of instances in a very small amount of memory and disk space. And that's really, really good. Gives us what we call density, lets us do a lot with a lot fewer resources. All right, I've talked about images and containers, and I do make the mistake a lot of times of suggesting that they might be interchangeable, but they're not. The Docker image is the bundle that's going to run. That's the picture of what we're going to spin up. The container is a running or maybe a had been running instance of an image, right? So the image is what you have on disk, and then when I want to instantiate an instance, I spin up a container using that image, and that has the read-write layer overlaid on it. So if you think of it in terms of cookie cutters, right? The cookie cutters, those are the images. The cookies that you're spinning up with them, those are the containers, right? You're always going to interact with the containers, and then at some point you're going to create images to use to spin containers up. One last piece of vocabulary here is registries. Registries are very important in the Docker ecosystem. It's just a repository of Docker images, right? As we're going to see, one of the really strong pieces of using Docker is that you don't need to reinvent the wheel. You can use somebody else's image and you can build on top of work that others have done. And we get those pieces of work, those images that other people have done from registries. The most popular one is the Docker Hub. It's a public Docker hosted registry at hub.docker.com. We're going to use that, and if you have an account, you can go ahead and log into it now because we are going to be able to push stuff to it if we want and at least see what it looks like. There are some other alternatives. You don't have to use the public hosted Docker registry. Google has one, Amazon has one. There's a service out there called Quay that has some cloud alternatives, right, that you can push stuff to. There's also some on-premises alternatives. There is Sonatype Nexus, which is something we work with a lot. A lot of people use that as their software repository, and you can use that as a Docker registry as well. JFrog, very, very similar software, that also can be used as a Docker registry, as can Quay as well, right? So all of those can be hosted on site, especially if you work in an environment like I do with the federal government where you don't like to send your software outside. It'll all has to stay in a controlled environment. A lot of times you can't get out to the cloud to do some of this stuff. So on-premises alternatives are valuable. But we're going to play today with Docker Hub. We're going to use the Hub to download some stuff. We're going to be able to push stuff up to Docker Hub. So let's go ahead and get started. So what we're going to do here is we're going to start with our first Docker container. I'm going to show you some commands. I'm going to go ahead and run through them. You should go ahead and pause the video at any point if you want to take some time to do it yourself. I'm going to give you plenty of time. I'm going to do it, but obviously I've been through this before, so I may go a little quicker than you need to. So feel free to pause if you need a little bit extra time here. All right. So go ahead and log into the box you have prepared, or the box I've prepared for you. And we're just going to run this command, docker run hello world. It's just a container we're going to spin up, right? And so let's go ahead and do that. I'm going to go ahead and switch over to my VM that I've already logged into. This VM happens to be in AWS. It just has Docker Compose, and the Redis command line interface installed. There's nothing special about it. I've logged into the box. I'm just at the home directory. You can see there's nothing in there except actually the script that I pointed to right at the beginning of the video. And I can go ahead and start, right? Docker run hello world. And what we're going to see is right away it says I can't find that locally. I don't have a copy of it, so it's going to go out and it's going to pull it. And we didn't tell it where to get that from, but it turns out that because we just left it default, pull it from wherever you want, Docker is set up, no surprise, to use the public Docker registry, Docker Hub, as its default source. So it said hello world. Hey, I don't know, I don't have an image called hello world, so let me go out and see if there's one called hello world out on Docker Hub. Sure enough, there is. We see it pulled it down fairly quickly. The pull was complete. It gives us this little SHA. We'll start seeing those in a lot of places, right? That it pulled down. It spun up a Docker container with that image, right? Since it was done. And the Docker container ran and just printed out this message. That's all it did. It's a hello world message, right? And it talks you through what it did, right? It went ahead, we typed Docker run, told it to pull hello world if it didn't already have a copy. It did. It spun up that container. And then when it was done, it went ahead and showed us the output from that, right? So we were able to do it. Now, if we want to do it again and just type Docker run hello world one more time, we'll see, wow, it went really quick that time, and it didn't have to download it again. Why not? Well, because it already had it on disk. It already had downloaded it. So let's take a look at the pieces it went through. All right. Docker run hello world. It downloads the image if needed. It starts a container. It allocates a file system, adds that read-write layer that we talked about, just a thin layer at the top. We're going to see a little bit more into this, how this works in just a few minutes. It sets up a network interface, gets an IP address for it, executes the process, captures the output, and then when it's all done, it exits the container and the container shuts down, right? There's different ways to affect the way that runs, but that's what happened here. After I run any of these commands, I do have links at the bottom for the reference guides on Docker's site for the documentation they have, so if you want to read more into it, right? But I'm going to go through enough detail as you can hopefully understand what we're doing and why we're doing it without having to get into the nitty-gritty of all the options and everything that can happen. All right, so we were able to spin up a Docker container. Very, very easy. All we did was Docker run and the image name, and we got a container formed from that image, right? Very, very easy. Okay, let's bring up an image that we can interact with, right? So this is one thing we can do. We can interact with the Docker container by typing docker run -it ubuntu bash. Okay, so go ahead and let's try it, and then I'll talk you through what it just did. I'm back at my screen here. I'm going to do the docker run -it ubuntu bash. And I can see this is pulling down. It couldn't find Ubuntu latest, right? So it went ahead and pulled it down. You notice it pulls down several layers this time. Last time it only pulled down one in the hello world, which makes sense. That was a fairly easy program. This one pulls down 4 different layers. Once they're all pulled down, it goes ahead and spins up the image and then drops us into a command prompt, right? And you notice when I was typing my messages before, I was at this prompt on my VM that I was using, but now I seem to be dumped into this root prompt. I'm logged in as root. And what I'm actually doing here is I'm interacting with the Docker container that I just spun up. So let me talk through it a little bit, and then we'll jump. Let's go ahead. I'll go ahead and exit from that. You'll notice I'm back to my regular prompt. And if I go ahead and I run it again, the same command, you see it didn't have to pull anything down because it had the image already local, right? I can go ahead and exit again. But let's go ahead and talk about what we just did, right? So Docker run, we're going to pull down an image and use it, right? Ubuntu is the name of the image this time. So it downloads it if needed, which it needed the first time, not the second time. It start up a new container with that image. But we gave it this -it, right? And -I means to keep standard in open so we can type with it. -t says allocate a terminal so we can see what's going on as we're typing, right? And then we told it, once you spin up that container, go ahead and run the bash command on it, okay? Every container or every image that you make has a default command that it's going to run. And in this case, we said, regardless of what the default is, I just want you to run bash, which is what dropped us into the shell. Okay. Turns out in this case, if we had not typed bash, bash is the default command, so it would have run the same way. But anyway, it executed the bash process. When we exited out, we captured all that output. When it exited out, it exited the container, and the container was no longer running. Okay, so we spun up not a full VM, just a container. It was much quicker than booting up a VM if you've ever done that before. Happens to be Ubuntu Linux that we're going to interact with. But let's go ahead and let's play around to create our own Docker image, and we're going to do it in an interactive way. All right. So Docker images are layered. We're going to see that in just a few minutes. We talked a little bit about it, but I just want to give you a heads up it's going to happen again. We're going to go ahead and start with the base image, right? We're going to interact with it. We're going to keep the standard in and the terminal open. We're going to do it on Ubuntu Bash, and we're just going to go ahead and manually install some software, run some software, and see how this all goes, right? So let's start with Docker run -it Ubuntu Bash. Okay, so let's give it some blank lines here. We'll get started. Docker run -it Ubuntu Bash. It's going to drop me into my root prompt. I'm going to run this command, apt-get update, which is the Ubuntu command to say go out and get a list of all the software that's available to you. Then I'm going to go ahead and type apt-get -y install Fortune. Look in your catalog and install the program called Fortune. The -y just says, I don't want to have to answer any yes/no questions. Just assume the answer is yes. So you see it's done, right? And so that's all finished. I can go ahead and type user games Fortune. There you go. I got a fortune cookie, right? Just a random quote from somebody or from several people in this case. Let's look at another one, right? Every time I run it, I get a very different quote or a very different fortune cookie message, right? So don't exit out of this. Let's leave this running. I want to talk a little bit about what we just did and see a little bit about the image naming we did. First, we've already used a couple image names. One was Hello World, one was Ubuntu, right? We didn't give them any repositories. They come from the official repository. Anything without a slash in the name from Docker Hub is the official produced version. So in this case, Hello World is something that the Docker project maintains, and Ubuntu is one that they maintain. So we just grab those. But I could also have something that was my own, and we're going to go ahead and create this one. For me, I'm going to call it Gotimer Fortune 1. You should call it your name, especially if you have a Docker username or Docker Hub username, your username /Fortune 1. If you don't have a Docker Hub username, don't worry about it. Just make something up. You won't be able to push it anyway. But the convention is your username / the image name. All right, but that's not all there is to image names. So we're going to go ahead and create this. You're also going to notice that this, You're also going to notice this convention I'm going to use throughout. Wherever I say Gotimer in gold, replace it with your username, right? I'm just letting you know that's the way I have it. You go ahead and use yours. The rest of the image name titling is you could put a tag on it, right? As a colon, that would be the full thing. In fact, if you noticed when it downloaded Hello World, it said it actually couldn't find an image named Hello World, so it downloaded Hello World : latest. Okay, and what that meant was it wants the latest version of it. By default, it's always going to default to the tag called latest, but it could default to a tag that was a version number or a name or something else. And we are going to play with that as we go through this in a couple different cases when we get later into the exercise. But the one you want to see here in the workshop, your username /Fortune 1. That's what we're going to go ahead and create. So let's go back to our image. What I'm going to need to do is spin up a separate window. I do not want to use the window I was already in. So go ahead and log in again using SSH a second time. And we're going to go ahead in that separate window, and we're going to use a couple Docker commands. I'm going to do those in just a second. And we're going to interact with both of them. So here's my example. Let's go ahead in. This is the box I was in. You see I'm still the container I was in. You still see I was at the root. I'm going to go ahead and I'm going to log in a second time. Oops. I'm going to go ahead. Yep. Log in a second time. And hold on. Oops. I did that twice now. All right, let me try it one more time here. I'm going to go ahead and try it. I'm logged in. There we are. I'm back into that same box I was in. See, I'm still running in that window, not running anything in this window. I'm going to type docker ps. All right, and docker ps, when I run it, it's going to give me this output. It's going to tell me a couple things. I'll go through it in just a second. But if I switch back over to kind of highlight, talk a little bit about it easier, the Docker PS gave me a container ID, which was the SHA-1. I told you you'd be seeing those some more. It also gave me this name. I didn't specify a name for the image or for the container I was spinning up, so it picked two words and just spun them together for me with an underscore between them. In this example, it was Tender Franklin. If I go back to see what it showed me, it was Goofy Fermi, right? Those things are kind of interchangeable. I can use the container ID or the name, whichever one I want, right? So what I want to do is go ahead and in this window, I've got the container ID. I'm going to type docker, oops, somehow got caps lock, docker commit. I'm going to cut and paste my container ID here, right, just so I get it right. And I'm going to call that Gotimer Fortune 1, right? I'm going to call it Fortune 1 because we installed the Fortune cookie command on it. And there, I created the image, right? And it turns out I can also now stop the container I already had. I could use the container ID again. I'm not going to. I'm going to use Goofy Fermi. And there it stops. And now if I spin over to the other one, I see that it automatically typed exit. I'm back at my regular workstation prompt, right? So I created an image here. I took a copy of it and I used this docker commit command. Okay, let's talk a little bit about all those commands we just typed. First, right? Docker PS, Docker commit, either use the container ID or the name, and the name I want to give it, tag I want to put on it, and then I stopped it, right? And we see that the interactive session stopped. If I look at the commands, Docker PS showed me the running containers, told me the commit ID, told me the or the container, it gave me the container name so I could use it. There's also another command I could type, docker ps-a. So let me go ahead and try that one. So docker ps, there's nothing running right now because I stopped the one I had. But if I do a -a, it shows me all of them. And for those of you that were paying attention, you may have noticed that I ran Hello World a couple times. Those were the two I ran. I've run the interactive Ubuntu bash 3 times now, twice on my own, then again was Goofy Fermi, right? So it keeps track of all the ones I've run before, okay? I've stopped the containers. I have not removed them. They still stay around. They still have container IDs, okay? And we're going to see why that's important in a second. The next command we want to go through, we did the stop, right? We did the commit, we did the stop. But the stop, we either use the tag or we can use the container ID. We need at least 5 digits. So I just cut and pasted the whole 12-digit, I think it is, that hex that it gave me. If I had just typed docker stop F706B in that instance, it would have stopped it as well. Okay. The commit created the image. We're going to interact with that in just a second. Let's take a look at one other command we can do here. Like I said, those images, the containers rather, they stayed around. They didn't go away. I can actually look at the logs. If you were paying really close attention to the way I laid things out, what happens when you do a Docker run, one of the things it does is captures the output, then goes ahead and exits the container. It shows you the output at the end. But what I could do here is let's take a look at that Goofy Fermi log. Docker logs Goofy Fermi. And I can scroll back up here. I can see all the commands I ran, all the output, right? Here is my apt-get update. Here is my apt-get-y install fortune. I installed it. When it was all done, I went ahead and ran it once, and I ran it again, and then I ran it again, right? This is the capture of all those things that happened on it. Then you even see the exit that got thrown in when we did the stop, okay? So Docker logs, great way to look at the output of a running or a stopped container to see what's going on it, okay? So all those were kind of around what we were trying to do. The commit was the big one, right? We created an image. Docker commit creates an image from a running container. And really what it's doing is it's taking that top layer, the layer that we've been interacting with, the only layer that was read-write, and it has now stored that as a new layer it has, okay? Let's go ahead and try running it. And the way we're going to run it is docker run Gotimer fortune 1, so the name of our image, and then the command we want it to run with. So I want it to run user games fortune. So let's go ahead and do that. You can do this in any window that you have open now. We only need one from here on out if you want to close the other one if it's getting in your way. So let's go ahead and run that again. Docker run Gotimer fortune 1 user games fortune. And I run it. When I do this, remember all the steps it goes through. It checks to see if Gotimer fortune 1 is an image it knows. It is, right? We just created it. It creates a container out of that image, and then it runs the command user games fortune. And we get the fortune output, and then it exits when it's done. If I run it again, we get a different one, right? Because we are just running that user games fortune. If I go ahead and do a docker ps-a, I can see that, hey, I ran those extra couple, right? Unruffled Moore and Hopeful Goldberg, those ran it. And they were the Gotimer fortune 1 image that ran the command user games fortune, right? So I can see all those happening. I could look at the logs for those if I wanted to see those again, right? Let's take a look at Hopeful Goldberg, right? That was the only thing that we had from that. It was the only output that time, okay? All right, so we have now downloaded Docker images from the Docker Hub. We've gone ahead and created containers out of those images, and we've used one of those images and layered our own information on top of it, the fortune cookie game, and we're able to run it now. We've done all of that interactively, right? But one of the big advantages of Docker is we're using it in DevOps, and we're using it to do something called infrastructure as code. We want to do as much with code, as much in an automated fashion as we can. So doing stuff interactively, while it's possible, it's an interesting introduction to how Docker works. This is a good way to go ahead and get started, but it's not really the way we're going to interact with it most. We're going to use something called Docker files, right? And we're going to start out with a very simple Docker file right at the beginning. Let's go ahead. A Docker file is going to contain the description of an image. We're going to start with an empty directory. Everything under that directory is going to be in the Docker image. And we're going to go ahead and we're going to type this short Docker file in. Anytime I have any more than just a line or two that you're going to type, anything that might be confusing, I'll put a gist to it up here. You can go ahead and look at that. And that's just the, you can go ahead to that URL if you want to double check that you're typing everything the right way so that you don't have to type try to fix typos and stuff. I personally like to type things out when I'm learning because it helps me learn things quick. But if you're having problems keeping up or you just want to double check your work or you just don't feel like typing it, feel free to go ahead to the gist and grab that. All right, we're going to get to this in just a second. This is a 3-line Docker file. I'll talk through it as we go ahead and build it. But let's go ahead back to our image, or I'm sorry, our workstation. And here's what we're going to do. We're going to create a brand new directory. We're going to call this one Fortune 2, right? We're going to create a Docker file with the capital D. This is important. The file name has to be uppercase Docker file by convention. We're going to go ahead and put our data in there. I'm going to use Nano in this case. It's a very simple text editor. If you know Linux and you're familiar with other text editors like VI or Emacs, or hey, even if you want to use Edlin, go for it. All we need to do is come up with an image like this. I'm going to show you how to use Nano just because it's very easy to do. Okay, so let's start out. I'm going to go ahead and type clear here just to get an empty screen. And let's go ahead and make sure I'm back at my top level directory. That's what the CD is going to do. I'm going to make a directory, Fortune 2. I'm going to go ahead and switch into that directory by CD, Fortune 2. And I'm going to type nano Docker file. And I'm going to get this blank screen Docker file. And let me go ahead and start typing out the commands. First, I'm going to say from. I want Docker to start with this image, Ubuntu, the latest version of Ubuntu, right? The same one we've been playing with so far that we just did, right? I'm going to go ahead and run on that image once it spins up a container with that image, 2 commands, apt-get update and apt-get install-y fortune. And for those of you that remember when we created it interactively, these were the 2 commands we typed in order to get the fortune command installed. We grabbed the catalog of software that Ubuntu has, right? That was the apt-get update. And then the double ampersand in Linux means if that command works, go ahead and run this other command. So the next command is go ahead and install the fortune with the fortune program with the -y. So we don't have to answer any commands because obviously we're not going to be here. This is a Docker file. We're going to do this automated. And we're also going to set one more thing. We're going to set the default program to run when we instantiate the container, when we build it from the image. This is what we want to run unless somebody tells us something different, right? So just those 3 lines, right? Once you get them done, once you have them typed in, you've double checked it, you can use your arrow keys to move around in Nano. To get out of Nano and save your file, you're going to go ahead and hit Control X. It's going to ask you if you want to save the modified buffer. That's the file we're typing in. You want to say yes, Y, to enter it. And then it's going to make sure you get a chance to choose the file name. We told it we were going to save it as Docker file, so it prompts us with that as the default. So I can just hit return, and we're back. And now if I check here, I see one and only one file. This is really, really important in my Fortune 2 directory, Docker file with a capital D. Okay, that is really, really important. If you find that there's other files there, for instance, the Fortune 2 directory is there, and all it means is you skip the step to CD to the Fortune 2. You can use a move command, or you can go ahead and redo these commands to get into that directory, because we're going to need to be in that Fortune 2 directory with nothing but the Docker file in there to run our next command. And that next command is going to be a build command. We're going to give Docker a command to say, take the Docker file I have right here, and let's go ahead and build an image, and we're going to tag it Gotimer Fortune 2, or your username / Fortune 2, and we're going to do it in this directory. The thing that most people mess up on this trying to copy this command is forgetting that dot. All right, it's really, really important that you get that dot, because that says use this directory is where we're working from. So let's go ahead and switch back over. I'm going to go ahead and start those commands. Like I said, I'm in the Fortune 2 directory. I have one file in there, the Docker file, and I'm going to type docker build -t Gotimer Fortune 2, this directory, the dot, that means this directory. We're going to see it spin up and do a couple things. One, it's going to go ahead and use the Ubuntu latest image. Then it's going to go ahead and run those commands that we gave it before, which were the apt-get update and the apt-get install fortune. And it's going to look very similar to what it did, what it looked like when we ran them ourselves interactively on our Fortune 1 image. It's going to spit out all the data from that. And when it gets to the end, this step 3, it says it's setting slash user slash games as the default command. It doesn't actually run that command. It's just saying that's the default command when I run this image. At the end, it tells me it was successfully built, and it tells me it was successfully tagged as Gotimer Fortune 2 latest, right? So let's take a look at all those steps again. The Docker build builds the image using the Docker file in this directory, the dot because it was this directory, right? The -t says tag it as Gotimer slash Fortune 2. The dot says the files in and below this directory, including the Docker file with the capital D that we wanted, right? And when we ran that, we get the successfully built. Now it turns out, because it's already built, because those layers are already built, I could go ahead and run that command again. And notice this time it happens much faster. It ran through the same steps, right, in the Docker file from the latest. Well, it already has a copy of Ubuntu latest, right? We've been playing with that already. It runs these commands, and it doesn't have to do them again because it uses the cache. It says, hey, I know what that layer looks like. I already have that layer, right? In fact, that layer with this number is the one it's going to use. Same one we ran before, and then it's going to set that command as slash user games fortune. It successfully built it, went ahead and tagged it as Gotimer Fortune 2 latest, right? So let's go ahead and run it this time. Docker run Gotimer Fortune 2. There we go. We ran it. We didn't need to tell it to run user games fortune this time like we did with Fortune 1 because we told it what the default command was, right? I can go ahead, I can spin it up. I can do a Docker PS -a. I can see that we run it a couple times, right? In this case, Fortune 2, it ran a shell user games fortune, created new images, spun them down, it was done, right? Everything just like we did before. Okay, so this is definitely much more in line with the way we're going to interact with containers and build containers. Not usually interactive. It's more often we want to build it as part of a pipeline or do something with a with the Docker file so we can do this in an automated fashion, scripted somehow, so we don't have to put manual steps. Manual steps never get manual steps are easy to make mistakes on. You can't consider it 100% repeatable if it's manual, right? If it's automated, we know the computer's going to do the same time after time after time. So consider looking at the logs here, right? We can do a Docker logs. Let's look at bold booth just because it's short. That was one of the ones I spun up and ran. And there we go, right? We can see all the output, right? We can see. But let's take a look at a little bit more of what we have here. We had that Docker PS before. Let's look at the images we've pulled and created. Okay, I can see 4 images that I've pulled down, right? I can see the relative size. I can see what we did with them if I want to get into some detail. So this Docker images, or I could even tell it specifically what I want to do, which image. I can see one of them. Right, we can see the image ID, we can see the size of it. You can see these are fairly small images. That said, they're megabytes in size. We'll talk about making these a little bit smaller later, but you can see a little bit about them. So let's go ahead and take a look at this. Right, the images we pulled and created. We can look at them individually. We can look at the whole list by just giving Docker images. The other thing we can do is we can actually see a little bit about the layers that were involved. So let's take a look at our Fortune 2 and see the different layers. And I'll walk you through these in just a second. But the big thing to look at, the big thing to look at is we see that a bunch of these layers were created 4 weeks ago. That's our Ubuntu image. In this particular picture, we'll see in just a second what it was when I did this one. And then there's the steps we put on top of it, the apt-get update and install, and then this no op, right? Nothing happened here, setting the default command we were going to run, which was bin shell -c user games fortune. It put the bin shell -c for us, which just says run this as a shell command. We'll also know if we look down a little bit, the last command it did for the Ubuntu piece, it's 0 bytes in that case, but the last piece it did there set it to the default of bin bash, right? So the default command for the Ubuntu image was bin bash. Then we changed it to user games fortune, which scrolls off on this case. But I can see those. I can see the image IDs, really the layer IDs, and the commands that were run to create them. So let me go ahead in and do that for this command. Give us some space here. Just do this Docker history. Oops, Docker history, Gotimer, fortune 2. And then we can see in our case, these were created, I guess the image I'm running now for Ubuntu latest was only created 8 days ago. And 6 minutes ago, 6 minutes since we started talking, we ran these commands. And we could see that the apt-get update, apt-get install -y fortune created this image that was, in our case, 24.1 megabytes in size, right? We took whatever the original image was and we added 24 bytes of layers on top of it. And you can also see that the 4 layers that it downloaded for Ubuntu, if you remember, it had 4 layers. Those were them. One of them obviously was really small, literally 7 bytes, right? But one of them was fairly big, right? It threw down this no op, 0 bytes to set the default command. We went ahead and threw a layer on top of it because we had one run line in our Docker file, so that created one extra layer. And then another piece for the no op for setting the default command for us, right? So we have 5 layers now, this one and these 4 in our image. These 4 Ubuntu ones are the same ones we used when we just did the Ubuntu the Docker run -it Ubuntu bash, right? It spun up those 4. And it's also the ones we used to build Fortune 1 on top of, and now it's also the one we used to build Fortune 2 on top of, right? And I can check that out. If I look at Fortune 1, I can see, look, that's the same image ID there and there, right? Same one. This 1D622, 1D622, okay? That means if I had these running in multiple windows, I would not be taking up extra memory. It would use the same layer in memory. And again, this is going to help us get higher density. All right, so that was a good start. We've used automation now to create a Docker image. Now let's go ahead and do something a little bit more with it, right? We've got to see how the layers work together. We're going to pay a little bit more attention to it down the road. Okay, let's start with a bigger Docker image, okay? Here's the steps we're going to go through. This is going to set up a Java Hello World program. I'm going to have you walk through these steps, but what I need you to do when you do this is create a brand new directory for it, edit the Docker file. We're going to see the Docker file in the next slide, and then we're going to edit and save it just like we did before. We're going to end up with something very similar. When we edit and save it and we go to the ls to make sure, we want to make sure that we only have Docker file in there, nothing else, just Docker file in that command, in that directory. Again, we want to make sure we're in our own directory because everything that we do on the build, everything in the directory we build from is going to be part of this Docker image. And we're going to play with that a little bit more down the road. But for now, let's go ahead. I just want to show you how to use your editor. We're going to go through these same commands. Here's what the Docker file looks like. All right. It's fairly long. I'm going to go ahead and leave this up on the screen. Of course, there's a gist there if you want to jump to it. But if you're following along here, you can go ahead and pause. I'm going to go ahead and pull it down, type it in, and run through it on mine, and then I'll jump back to here. So let's go ahead and see that. Just a second. I'm going to do a CD, jump to my top level directory. I'm going to go ahead and do my make directory, Java, hello world. I'm going to CD into that directory, and then I'm going to use nano Docker file with a capital D to create this file. And let me go ahead and pull that up. Type it out. I'm going to cheat and use the gist so I can talk through it and paste it in. And here are the commands we have. Oops, this is not the commands we have. This is the wrong one. So let me go ahead and exit out. We're not going to save the buffer. I'm going to go ahead and I'm going to type them just like I was going to have you do it. My cheating got me ahead. All right. So first, just like we started the last one, Docker, the image we're going to use is Ubuntu latest. And we're going to run this command. This command is a little bit more complex than the one we used last time, although it starts out the same. apt-get update to get the catalog, and apt-date install -y. We're going to add this no install recommends, which will just say anything else that you wanted to go along with it that's suggested to go with it. We don't need it in this case. I'm going to do a backslash. This backslash has to be the last character on the line. And all that's going to say is this is a continuation character. This next one is really on the same line. I just don't want to have to scroll so far over. So I'm going to install these programs, these packages in Ubuntu. Default JDK headless, Maven, and Git, 3 of them. All right. And after that, another continuation character. And after that, I'm going to do this one other command. And this happens a lot in Docker files, which is why I'm actually putting it here, even though we may not care too much about the size. But I wanted to show you what it does. That update grabbed a list of all the software that was available to this Ubuntu distribution. We went ahead and installed, in this case, 3 packages before we just did one, which was the Fortune package. Here we do 3, a JDK, so Java Runtime and Developer Kit, the Maven build system, and then Git, so we can check stuff out. And when we do that, we no longer need this catalog. So this remove -rf var lib apt lists all the files in there. We're going to go ahead and remove it to cut down the Docker file a little bit more. So like I said, you see this in Docker files a lot. A lot of Docker images are based on Ubuntu, and this is a fairly common way of doing it. Okay, so we did one run there. That's very similar to the one we had before. I'm going to do another one here. Run git clone https github.com Coveros with a capital C hello world.git. Okay, so we've installed Git now, and then I'm going to run git clone to check out from GitHub, just from the public GitHub, this hello world program that's already sitting there, right? And that just happens to be the URL to it. I'm going to throw in another command into my Docker file here, workdir. I'm going to switch to that hello world directory. When Git clones it, it's going to clone this hello world repository onto my Docker container. I want to switch into the directory that it created, the hello world, because by default that's what it creates. And I'm going to do even another command, which is Maven clean package. If you know anything about using Maven, Maven is a build system for Java programs, and clean package says go ahead, start with a clean directories, right? Wipe out any previous runs, which there haven't been in this case, but it's just normal practice. Do a clean. And then packages. So do the build, package it up into, in this case, it's going to be a jar file that we're going to be able to run. And then when it's done with that, packaging it, we're going to set the default command to this. Now, this is a little bit more complex because we're going to give it several different items to it. It's not just a single line or a single word. So we actually put it in an array. And we're going to run the command Java-cp with the Java with the class path of hello world / target / hello world -1.1.jar. And then let's go ahead and put the comma, continuation character. I'm going to go ahead and under here, com.coveros.demo.hello world capital hello capital world and then the array. And let me talk about what this does. If you know the way a jar file can be run from Java, you give it a class path, you point to the jar file you need, and then you run a class. So this is the class that the Maven is going to compile. It's going to put it into this jar file. We didn't tell it where to compile it, but by convention, we were already in the hello world directory. By convention, Maven puts it in a directory called target, and the POM file, the directions for Maven that are in that Git repo, tell it to call it hello world-11.jar. So our default command will be to go ahead and execute that jar using Java and start up that class, which is a hello world class. Again, we started with the Ubuntu. We went ahead and installed the JDK, Maven, and Git. We cleaned up after ourselves. We checked out this Git repo. We went into that Git repo. We went ahead and built it using Maven, and then we're going to use Java to run it. I've got everything set in my Docker file. I can go ahead and Control X out. I want to save it, so I hit yes, and then enter because I want to call it Docker file with a capital D. And if I do the ls, I see I'm in a directory called Java Hello World with Docker file as the only file in there. And I'm going to go ahead and build it. So we're going to go into this process of doing these things over and over. All right. And they are build, build, run, run. So go ahead and pause if you need time to catch up to me here. But let's go ahead and take a look at what we would do once we continue. We're going to build it just like we built our, in my case, the Gotimer / Fortune 2 image, right? Using the docker build-t, give it the tag name, say my regular directory. But I'm going to go ahead and build it twice because I want to make sure that I did it right. And we're going to see that it doesn't do any actual work the second time. It keeps all those layers, right? And it's just a good reminder that I've done it right, right? And then I can run it. And if I run it twice, we should see it run. It tends to spit out the hello world with a current time so we can see that it's different on each run. So let's go ahead and do that now. All right, Docker build, tag it, Gotimer, Java, hello world, that's, Java, hello world, current directory, don't forget the dot, and we'll see it go ahead and do it. We'll see it go through the same commands that we're familiar with, all right? It's installing a lot more this time, a whole bunch of different packages that need to be, that are involved in building, in installing the JDK and installing Maven and installing Git. So the first build is kind of slow, so it does all of that. Has to do all the installing. We'll let it get through those. Still installing. It's on Git now. Gets them all done. Lots of pieces to set up with it. All right. Now it's going to go ahead and start doing my clone of Hello World. Once it's done, it's going to go ahead and do the Maven build. Now, if you've ever seen Maven build before, you know it. The first time you build on a clean system, it has to download the internet to it. Lots of files come down, all sorts of plugins, all sorts of dependencies that go with it. So there's a lot to do. It takes a few seconds to do. We see it took 14 and a half, 15, almost 15 seconds to do that build, and it built our jar. And when it got done with that, it went ahead and said the default command to Java with the class path of hello world target / hello world -1.1.jar. Same command that it built here, same thing that Maven, this is Maven output here. And then we're going to run this class, right? So we see it was successfully built. we see it was successfully tagged. If I do the build, in other words, do the build the second time, we see it goes through almost instantly. Each time it noticed that it already had a layer that had that information on there. Okay. And let's go ahead and do the Docker run this time. Docker run, Gotimer, Java, hello world, and there it goes. Current time is 10:09 p.m. on May 2nd when I'm recording this video. It's actually not 10 o'clock, that's actually GMT, so it's a little bit more reasonable time for me to be working on this. If I run it again, you see it's 15 seconds later, right? And I can keep doing that. Each time I'm spinning up a new Docker container, right? I am starting with that image and I'm spinning up a new container and throwing out the output. Let's go ahead and take a look at this, right? We already know how to look a little bit into this after we do the build, run, and you get that working. Let's go ahead. We can use the Docker images command to see it and the Docker history command to kind of see the sizes and the different layers that are involved, right? So first, take a look. We'll see what it actually turned out, but last time I did this, before when I made up the slide, it was 571 megabytes, right? There was a lot of software we threw in this. And if I look at the history to see where all that came from, we can see there's a couple of big different layers in here. The first one, right, our 4 bottom ones or 5 bottom ones really, right? We know and love those. That's Ubuntu, right? 63.2 in this case for the Ubuntu latest. Then on top of that, we ran that apt-get that ended up throwing almost a half a gig of information on there. And that was the JDK, Maven, and Git, those programs on there. And when it did that, it's half a gig. So now we're getting into something fairly big. This is not the type of binary we want to be passing around as much as possible. But hey, it's not the end of the world. It's less than a gig, but still, that's a big chunk. We're going to talk about shrinking that down in a little while. We see it did the git clone, right? Again, a second run command in our Docker file means another layer thrown on top of it. This one happens to be fairly small, but it's just the git clone. We noticed changing the directory is a no-op. It took 0 bytes. But then we did the Maven clean package, and all the Maven stuff that got downloaded and building it and compiling the jar all ended up taking another over 9 megabytes. And then we set the default. Right? So let's go ahead and see if that matches up with what we got here. Docker image, Gotimer, Java, hello world. Ooh. Docker images. There we go, right? In this case, it's 618 megabytes. And if I go ahead and change that into Docker history command, we can see we started with a almost 73 megabyte image, right? We added over half a gig of data. Git clone wasn't much. The compiled version wasn't much, but really that half a gig, man, that really added up, right? So now we're at a 618 megabyte image. It's good. We can pass this around. This could be something we threw up in our own image repository or into another image repository, and we could see it. But this is something that is a little bit big to be carrying through our pipeline. Right? I wouldn't want to be copying this around or emailing this all over the place or making this available for everyone to have to download at that size and run multiple copies because, it is sizable, right? Although, again, if we're running this all in the same box, all those images, all those layers are shared because they're immutable, they're read-only. But let's see how we can shrink that down some. Okay, so a smaller Docker image. I'm going to go ahead. This was the one I cheated on before that you saw me cut and paste and undid. We're going to go ahead and change our Docker file. I'm assuming you know how to use nano now. We're in that directory already. We're going to make changes, and the only changes we're going to make are these ones in red, right? We're going to replace some stuff. We're going to add some new lines. You can start with the gist if you want. But we're going to go ahead and make some changes to do something called a multi-stage build. All right, so let me go ahead and pull that up. Oops. All right, I'm in my directory. I see I only have a Docker file in there. If I go to nano Docker file, it pulls it up this time, right? Because we're only editing it. The first thing I'm going to do is on the end of this command, I'm going to type as development. So I'm going to say this first image I'm working with, because we're going to do a multi-stage build, is going to be called development, right? And all my development is going to be everything through there, right? It's going to be go ahead and install the development environment, which was our JDK, Maven, and Git. We're going to go ahead and clone it. We're going to go ahead and build it just like we did last time. But then we're going to take a change. We're going to start with another from command, right? And what this is we're going to say, so you built that one, let's call it development. That was our Ubuntu. Now we're going to start with a new image, an image we haven't seen before. This one is called OpenJDK Alpine, and this one I'm going to call runtime, right? So I have my development, I have my runtime. And on my runtime, I'm going to start with that, my Alpine. The runtime and development are just names I made up. They don't have any special meaning. But I'm going to copy from development, so from our Ubuntu image that we went ahead and built the package on, I'm going to copy /hello world /target /hello world-11.jar, the file we created, and I'm going to go ahead and put that in my root directory. So it's just going to be called hello world-1.1.jar in my root directory. And so now I can go down here and I can get rid of hello world target, okay? Because on my Alpine image, on my runtime image, I don't have that hello world target. I just have the jar that I just copied over. Okay, we're going to see how this works, and hopefully it will make a little bit more sense once you actually see it in action. But we really didn't make many changes here, other than to do our build on one container, copy over the results, just one file from that, and then go ahead and run on a different container. So let's go ahead and save this. Control X, yes, return. I'm in a directory with only the Docker file. We're going to see a little bit about what we did. This multi-stage build, we're going to reuse files from a different image using multiple from statements, right? We called the first one development, and then we copied from development to use that. Okay, the image we're actually using, let me go back. The image we're actually using is called Alpine Linux. Ubuntu is great. We use Ubuntu all over the place, and a lot of Docker images are created using Ubuntu as the base. But sometimes you don't need all of Ubuntu. So we use this thing called Alpine. And Alpine Linux is a really small, tiny little 5 megabyte, not 60 megabyte, 5 megabyte Linux distribution. It has a huge package repository. It's security oriented. It's really easy to use. And it tends to be the basis of a lot of Docker images built just like we just did. So let's go ahead and let's do our build, run on it again and see what we can come up with. All right, so I'm going to switch over, right? We're going to just run that same build command we did before. Docker build -t Gotimer hello Java hello world dot. We're going to see it build it. We see, hey, it actually already had a lot of those pieces, so it doesn't need to rebuild those. But then it gets this next from command, right? And it's going to go ahead and pull down Alpine. It's fairly small. It's going to copy the file. It's going to set it over. And there, now we've got a new Gotimer Java Hello World latest. If I build it again, you see everything happens really, really quickly. So everything was cached this time, not just the first 5 steps. And if I do the Docker run again, I can see hello world. All right, this is a little bit later since we started. Now, it didn't have to rebuild the first step, right? it already had it. We actually see it remove this intermediate container. You'll see that actually through the commands where it gets rid of something, an image we were already using. We do the build, run, and we can go ahead and we can take a look at that again, and we can see just using the images command and the history command, we can go ahead and see that this is going to be a much smaller one, right? Last time it was in the 60s down here. This time we're talking about 5 megabytes. And let's actually take a look at the important pieces here, right? Heck, let me see if you can make sure I'm not sitting in front of that. I am actually sitting in front of it. Let's go this way. Here we go. There we go. I'm a little bit more out of the way now. You can actually see the 4 megabytes down here. This one, last time it was 618 megabytes. This one is going to be closer to 100, right? And in this one, it's 100 because we started with 4. We went ahead, did our builds, but then we got rid of all the JDK, the Maven, the Git, all the plugins we downloaded for Maven that ran, right? And we just copied just the piece we needed into this 100 megabyte file that has the Java. That was the OpenJDK Alpine distribution. So Alpine Linux, the OpenJDK on top of it, and then the file we copied, which was only a couple kilobytes. So we only end up with 100 megabytes. Let's see what that really looks like for me, right? Go ahead and spin back here. All right, so Docker, images, Gotimer, Java, hello world, right? 103, just like we saw last time, and the history on that. All right, so let's take a look at some of the files here, right? Again, 4.41, so it was the same file. This 98.2, that's the Java runtime. You can't see it here, but that's all it was. It's the Alpine image with that thrown on top of it. Then we copy the file over, which is our hello world.jar, and then we set the command. 103 megabytes. We saved 500 megabytes because we had, well, almost 600 megabytes that we had in the Java JDK, in the Maven, and in the Git, and we replaced it with just the OpenJDK sitting on top of Alpine Linux. So we saved ourselves 500 megabytes. All right? And again, works the same way the last one did. All we're doing is running on Alpine Linux, not on Ubuntu Linux anymore. All right. This is something that's very, very common when we're building, right, to create this Alpine image of it. But let's take a little digression here. Now we've built something. It actually runs, okay, it's hello world, and it just gives us the current time. Not much to it. But let's say this was something we wanted to keep, right? We've gone through a couple iterations. We did it manually, right, or interactively. We went ahead with a simple Java Docker file. Then we went ahead and saw how to make a multi-stage build to do with a more advanced Docker file. But let's say this is something we want to keep. What would we do with it? Well, we could go ahead and push this over to Docker Hub, okay? You'd have to log in, and you only do this if you have an account. If you don't, you can set up an account. Go ahead and pause and set up an account if you want. It's free. Or just skip over this if you don't want to bother. I'm going to go ahead and set up, go ahead and log in as Gotimer. I'm going to go ahead and push my Docker image up, and we're going to be able to see it on Docker Hub. So let me go ahead and run those commands first. Docker login username equals Gotimer. Like I said, that was my username. I need my password for Docker. Go ahead and paste it in. Now it's putting it here, but it does give me a warning. It's throwing this in this file unencrypted. So, I'm going to blow away this workstation when I'm done, so I'm not too worried about it. There are different ways to set this up so that they get stored in some sort of encrypted form There's instructions right there if you want to find more out about it. If you're doing this as part of one of our tutorials, I'm blowing away all the workstations when I'm done, but you know, take whatever care you want to do this. In any case, my next command is this, oops, sorry, switched off, is this docker push Gotimer Java hello world. It says it's going to push it. You notice a bunch of those layers already exist. Well, guess what? Those layers that already exist, they're the ones from Alpine Linux, right? Because Docker Hub already has those. It's not actually pushing all the layers up. It's only pushing up the ones it needs, which is the one we just created, the one I just compiled. It logs in, again, the convention, it's Docker Gotimer, gives it this name as the hello world, so it's my account. And so now I can actually switch over to Docker Hub. Let me refresh it. And there we go. This is my Docker Hub page. I'm logged in as Gotimer. Java Hello World was just updated a few seconds ago. 17 people have pointlessly downloaded a really pointless image, but you can see, right? It's something I could get to. I can actually see more information about it, how to push new commands up. I only have a latest tag. I could add a README and edit it. I could see different ways of building it. There's all sorts of things I could look in through here on it if I had a real repository. This one's public because it's just my Docker Hub. You know, if this was something company confidential or company proprietary, it might want to push it somewhere else so not everyone can see it, because that's me looking at it. But the other thing I could do is if you talk to any of your teammates, you could look at their repository, or you could look at mine, right? For me, it's coming up Gotimer when I log in. But if you were to go, right, sorry here, if you were to go to hubdocker.com, it's your login. But you could also look at somebody else's by putting their username in here, hubdocker.com/u and their username. So go ahead, if you're logged into Docker Hub, let me jump back to that, right? I can go ahead to hub.docker.com/u/Gotimer if I wasn't Gotimer, and I could go ahead and see all of Gene's images that he's posted, right? So there we go, right? There's another one up there, updated 2 minutes ago. It's a container that anybody could get to. So this is one way you could share things, right? And actually, this is the way we're sharing, like the Alpine and the Ubuntu and the whole world that were already built. They were just built by Docker, right? Actually, OpenJDK was not. It was built by, well, it was because it doesn't have an account name before it. That means it's a Docker supplied image by convention. All right. So let's go ahead and look at the next piece. All right. Let's talk about using pre-built images, right? We started doing it there with Alpine Linux, but the next step is we can go ahead and use pre-built images. Okay. So using pre-built images, we've already done some of that, right? We used the Alpine Linux, we used Ubuntu, but and we actually, the Alpine Linux one was an open JDK image, so we were using Java that was already installed from us, JDK that was already installed. What we're going to do now is actually use a couple other pieces so we don't have to set up some of the stuff ourselves. And this is definitely much more like the typical use of Docker. So we're going to start using this web server. It's also a load balancer and a proxy called Nginx. It's free, it's fast, it's open source. It's very popular with Docker users because it is so fast and small, and may not be as completely full-featured and as configurable as Apache, but it does what most people need it to do, which makes it a better choice since it's smaller and easier. So that's what we're going to use. Um, so let's go ahead and let's just start it by hand. We'll go back to the basics, just the way we used to. We start out working, right? We're going to run it. We're going to use a couple other commands this time. We're actually going to run it with a name. So before we were letting it come up with its own name, we're going to give it a name this time. Um, so Tender Franklin was one of the ones that's been in some of the slides. This one, we're going to call it dub dub dub. We're also going to run it in what's called detached mode, and we're going to set up some port mapping on it. So let's go ahead and switch over. And here we go. Let me go ahead and just, doesn't matter what directory I'm in for this one. Engine X. What it's do in just a second. Let's go ahead and run it. We'll notice can't find it, so of course it needs to go out and get it. Pulls down a number of layers for Engine X. Gets it. It's up and running, and you notice it didn't exit. It didn't show us what it normally did. Well, this is the detached mode, right? So we're saying we're going to run it, but we just want you to leave it running in the background. So let's go ahead and pull up a browser. And if we take a browser to the URL that you were at before, that you were SSHing in, the workstation that you have, so everyone's going to have one different, and I load it, I see that I have an Engine X, right? This is port 8080. 321.76.192 was my workstation number, right? And I can see that I have it there, right? Nginx is running, right? Nothing very impressive except that I stood up a web server, and it's running. You even see the message there: further configuration is required. We didn't do any configuration. We didn't do any installation either. That was kind of nice. But let's go ahead and take a look at what we did. And by the way, the convention here, I was using Gotimer before. Let's also look at the convention here. Anytime you see 44556677, that's just whatever IP address for your workstation, since you're going to hit your Nginx instance. And we are going to be doing some more of that, so you can keep that web browser open. Let's go ahead. Let's take a look at what we did, right? The Docker run, we know what that does. Downloads it if needs it, starts the container with the image. The name assigns the name www to the image, to the container. So now actually, if I hop back over here and I do a Docker PS, number one, I see that the image, Nginx, is still running, right? I didn't do a PS-A, right? But the name is www. It doesn't use some random words strung together, right? So that's new. Detached, so it's in the background, so it comes back to us and stays running. The other thing we did is mapped a port. So, So those of you that know a little bit about web servers, you know they usually run on port 80, and that's the way it runs here too. But we mapped port 8080 locally to port 80 on the container. So our 8080, we hit localhost uh, on the workstation, port 8080. We hit port 80 on the container, right? This does two things. One, it does the mapping. It says, hey, if you see port 8080, I want you to go to port 80 on the container. The other thing is this exposes port 80 on the container. Without this command, the container would not be open for anybody to hit anything on it, right? So we need to tell it to open up one of the ports. So we're doing 8080 to show how it works here. All right. So we see it's up and running. We've got it going. There's really not much we can do with this because it's not configured for any reason, for any to do anything. We have it just running there, right? You see the Docker PS says it's still running. It's been there for about 3 minutes. Let's go ahead and just do a Docker stop www. Right? I know it's called www because I named it this time. I don't need to look up the name. I could do it with the container ID just like in the past. But I'm going to do one more thing. You notice it echoes back that it stopped it. I'm going to go ahead and do a Docker remove www, because if I was to do, in fact, before I do that, let's look at the Docker ps-a, right? I see all those things I was running. I see I have one, and scrolled off a little bit. Let's shrink it up a little bit here. See if I can type it again. Slightly smaller. Nope, it's not wrapping for me, right? All right, but www, the Nginx, that name is already used, right? So what I want is to get rid of that. There we go. That was a little bit better. Www, it's already used, but it's still there. I need to actually remove it. So I'm going to remove www. So now it's not even listed in my PS-A. Okay. I want to be able to reuse the name. And that's really all it comes down to here. I want one called www, and we're going to see why. But I want to be able to stop it because we left it running, right? And I want to do a remove so that I can reuse the name. Okay. And when I look at it, there's a couple different ways to remove, and here are some commands, right? That just remove the stop container. I could give the container ID. I could give the name. I can do a force on the remove, which would stop it if it needed to be, and then remove it. Otherwise, it'll tell me it's still running, so I can't stop it. Then there's this other command, and this is just a handy one to note. Docker remove with this subshell of docker ps-a-q. The docker ps-a window will show us all the containers. The -q is a quiet output. It actually only send out the container IDs. And then the docker remove will take all those container IDs it removed and removed all your stopped containers. Right? So that's just a way, if you want to clear the board, get rid of everything you had done, you can run this command. We're not going to bother doing it now. We want to leave some of that stuff around in case we want to check it out later. Okay, so next step. We stood up Nginx. We have it running. Let's go ahead and stand up a static website by hand. Now, there's a couple commands here. There's just if you want to make sure you get the commands. The big one really is this long one at the end. But I'm going to go ahead and walk through it fairly slowly to do the steps and talk to you about what I'm doing. All right. So let's go through a couple steps here, right? I'll show you what it does. You'll be able to follow along. I'm going to go ahead and type cd, get back to my top level. Let me clear the screen here. Start at the top. I'm going to do a git clone, https github.com, Coveros with a capital C, states, docker demo, and I'm going to let that check out into a states directory, or clone into a states directory rather than just into states docker demo by default, just to make it a little bit easier to type. I'm going to cd into the states www directory. You can actually take a look at what's here. It's an HTML directory and a site. HTML's directory is actually the one we're going to use. I'm going to make sure I'm in that states www directory. I'm going to type out this command. This one is a little bit long, so make sure you get it right. We're going to do a docker run. We're going to give it the name www. I'm going to do a continuation character just because this command is fairly long. We're going to do home ubuntu states www html, and I'm going to map that to a directory that I know exists, and I'll show you in a minute how to find that out on the Nginx image, or in the container we're running. And I'm going to map those so that I'm using my directory, not the one that's built in. The one that's built in had that default message we saw last time. I'm going to detach it like we just did. I'm going to map port 80 to port 80, which seems kind of pointless, but I'll explain how that works in just a second. We're going to go ahead and let that run. It'll fire up. And now if I switch over to my browser, I can go ahead in here to the IP address I have and reload, and I get a static website. All right. So go back and take a look at what we had, right? What we did, we ran docker run -name www. We mapped this volume. I'll go through this on the next couple slides, and then detached port 80 to 8080 Nginx. Okay, that gives us the static, boring HTML page with just one state listed. It's a list of states and abbreviations, only California listed there. And if I go and take a look at the command, here are the pieces you didn't know in red. V takes home Ubuntu states www HTML. So we checked the path. We knew we were in that directory, and there was an HTML subdirectory there. And we map it to user share Nginx HTML as read-only. It turns out that HTML directory, this user share Nginx HTML, that's listed on the Docker Hub page. So if I go to Docker Hub, let's go ahead into Docker Hub. I'm going to go to just regular Docker Hub. And if I look up Nginx, I see the image here, right? And I can actually look down here, and if I was to scroll down, it'll tell me that that volume is where I want to map things, right? So I can take my directory and put it there, or as it points out, I could have copied it into the container, right? But there's some advantages. We want to do it this way. So that's how I look it up, right? That's how I find out that's what I wanted to do, right? So that's running. Let's go back to the slide here. We mapped that directory. So my HTML on my workstation became the HTML directory that Nginx was working from. And we mapped port 80 to port 80. So even though they're the same port, we're still mapping our workstation 80 to the container 80, and it exposes port 80 to the outside world. So we knew we could get into the container, okay? And that piece was important, right? And that let us go in here and see our state, right? Okay, just a boring web page, no big deal, but I could actually put things in that HTML directory locally right here, right? So I could actually, if I wanted to, I could nano HTML star east.html, right? And in here I could just do a simple HTML web page. All right, so I just created this file. It wasn't there before. I'm going to save the buffer, writes it out, and now if I go into my browser again and I just go to star east.html, hey, there it is, the one I just typed out. Great. Okay, so I've stood up a web server with nothing but one command on the command line. I didn't have to configure it. I pointed it to a directory where I can put my HTML files. It's static, but it works, right? It's something fairly simple. Let's get into doing something a little bit better than that, though, right? Let's go ahead and let's stop it. We're going to use the stop force this time, right? Let's do the docker remove force dub. So that's going to stop it and remove it. So again, we can reuse the dub, right? It's no longer a running thing. And we're going to move on to our next step. And we're actually going to do a full environment this time. And this is kind of the final. There's a couple steps to this, but this is the final run here. Okay, first, we're going to use PHP. It's a server-side scripting language. It's really meant for web development. It's simple. It doesn't need to be compiled. It's easy to read. It's very popular. Things like WordPress are written in it, Drupal written in it, right? Very easy to use. It doesn't need any compiling. That's one of the reasons we're going to do this piece here with it. We're also going to use this other free open source tool called Redis. It's a name value pair data store. Really popular on the web, very, very fast, lots of interfaces, including PHP, which is why we choose it. But something very easy to do. And so what I'm going to do is I'm going to go in, I'm going to stand up an environment with this one command that uses PHP and Redis and actually Nginx, and they're all going to work together. This is going to take a few minutes to come up, not even a few minutes. It's going to take a few seconds to come up. So I'm going to go ahead and kick it off, and then I'm going to talk about what it says. All right. So let's go ahead. We're going to go to states. Right. So we're up at the states directory, and if I do an ls here, I notice there's this file in here called dockercompose.yaml. Okay, and I'm going to do command docker compose. This is not part of Docker. This is actually a separate program that goes with it. But docker compose up -d. And we'll take a look at the docker compose YAML in just a second. It's in the directory. But I'm going to go ahead and run this, and we're going to see that it's going to do some things that we saw normally. It's building PHP, it's doing a pull. But one of the things it says here is creating network. Hang on, it's scrolling off. Let me try to stop it here. Creating network states default with the default driver. That's semi-important, right? Just keep note of that. Okay. You see it's doing some compiling and everything here. And the question is really, how did it know to do all of this? Now it's pulling Redis, right? It already had Nginx, everything's up. Didn't take that long, but let's take a look at what that did. Okay, I'm going to go ahead and just cat docker compose YAML on the screen here. All right, you see it's really not that long. I'll go back to the slides and read it out. It's a little bit easier to read. But like I said, note that it said states default. It's creating a network states default. Just keep note of that. All right, so our website Docker YAML here, right? It's version 3 of Docker Compose. We're using these services, right? YAML, if you're not familiar with it, is yet another markup language. It's popular for a lot of different things in DevOps and other types of configuration. It uses indentation to show hierarchy. It's sensitive to tabs. You can't use them. It's a little bit odd syntax. I don't like YAML. A lot of people love YAML, but this is how you set up Docker Compose files. Docker Compose is going to let us take a couple of different Docker images and compose them, put them together to work together. So what we're doing here is we're starting with, oops, I shouldn't have done that. We're starting with a Docker container that we want to call dub, just like we've been calling it. That's why we need to do the remove. It's going to use the image, Nginx latest. It's going to do this port map 8080 or 80 to 80, just like we did on the command line. It is going to map our current directory, www.html, to /html on the container. So we're not going to do the whole path this time, and we're only going to map to /html, and I'll show you why in a second. And that is because we're also going to map this file. Now this is just like the volume command we gave on the command line before, but this one is mapping our site.conf file that was in that same directory to the default configuration. And if I switch back here to take a look at what was in my www directory, and if I cat, yeah, it's small enough, cat www/site.conf, right? This is the configuration file for Nginx. We're actually giving it some configuration, and one of the things I point out is that the root here is /html, so I didn't have to use that whole other older root that we gave last time, so it's a little bit quicker. Okay, next, so we do that mapping, so I'm using, rather than the default configuration file, I'm overlaying my own configuration file. Rather than using their HTML directory, I'm using my HTML directory. I'm mapping port 80. That's on the www container. I'm also going to stand up 2 other containers. I'm going to stand up one. Let's start with Redis. That's just Redis latest is the image, and I'm going to map port 6379 to 6379. Again, we're just exposing it. Turns out that that's the default Redis interface, so I'll be exposing that so I can interact with it later. And that's just spinning up, just as if I did a Docker run Redis with -p 6379 : 6379, right? Nothing special about that one. You guys are familiar with that already. I'm also going to do one more build, and this one's a little bit more complicated and also in some ways more familiar to the way we've done it. Rather than an image, I'm going to do a build. Okay, I'm not starting with an image. I'm going to build a directory. I'm going to build everything in the PHP directory. I'm also going to map some volumes, HTML, just like we did in the last one. I'm going to map a log file configuration for PHP for reasons that'll become apparent later. But I've already set that up. You feel free to look through it. It's really more about the PHP container. But let's take a look at what that build does. Okay, if I go back here and look at my states directory, I have my Docker Compose. I had my www directory. I didn't need a Redis directory or anything. But in PHP, if I look at my PHP directory there, I see something very familiar. I see a log file I just mapped, but I also see a Docker file. And if I was to cat that Docker file, it's really simple, right? It's a simple from PHP with this tag 7fpm, and I'm going to run this command. Let me go ahead and let's talk about that a little bit more back on the slide here. Right, we're going to start with this Docker Hub image, and I could go to Docker Hub and find that, and I will in a second. I'm going to run Peckle, which is a extension loader for PHP to install the Redis driver, right? So it's a PHP Redis driver, and I'm going to enable it. And it turns out on the PHP image, having to do this is so common that they actually leave a command on the image that's specific to Docker to enable an extension that just got built. And in this case, it's Redis, so those match up. All right. If I go to Docker Hub again, and I go to the top here, and I'm going to search for PHP, look at the PHP image, one of the things I can see is this list of, the description, they moved it off. So supported tags. All right. So they actually have you go to a different site here. Here are the supported tags. Let me make this a little bit easier to read. We were using 7fpm. You can see there's a whole ton of tags, right? The one we want, FPM, lets us use a front end to do some compiling or to do some mapping, right? I could have done 7.3 FPM. Let's see where 7 FPM is, probably 7.45 FPM. There we go. So 7.45 is their current version, and the tag for 7.4 FPM and 7 FPM, or even just FPM, would have pointed all to that same Docker image, right? So that's where I got it. I got it from this list. If we were to scroll through, we see that some of them are Alpine based, right? We know what Alpine is now. Some of them have to do with Apache. I don't even know what the Docker one or the Buster ones do, right? But basically, we know where this one is coming from. I've done some research. I know that I want to use the 7 FPM for the way we're going to use it to do this dynamic mapping. Anyway, so it's all running. Let me go ahead and show you what that whole directory, the pieces we cared about were. We have the states directory with the Docker Compose, states.txt, we'll see in a few minutes. We have the PHP build coming out of that Docker file and the log conf that was there. We have our site conf that we were already used to. We had an index.html, but now we're actually going to use this index.php because we have PHP that can handle it. So we're going to go ahead and look at what we stood up, right? I know I have all of those running, right? If I do a Docker PS, I see I have 3 boxes. I was in the states directory. I stood up www, PHP, and Redis using that Docker, the Docker Compose up, stand them up, -D, so it did it detach, so it returned to my desktop here. And let's go in here. Let's go back to this directory and reload it. And I notice I don't even have any states in here now, but rather than a static, it actually says this page has had 1 visit, 2 visits, 3 visits. Every time I refresh, I get another visit. All right. So I keep reloading this in my directory, or in my browser rather, and I see that I get more visits coming up, right? But we're not using anything here except some dynamic PHP, right? As far as we can tell, we're actually using Redis, but I'll show you that in a second. Let's go ahead and do one more thing. Let's play with that Redis instance. I told you I have Redis CLI installed on the machines, and this is where we're going to use it. That states.txt file is just a list of Redis commands. So we're going to go up and we're going to feed it through this Redis CLI, which stands for command line interface -- pipe. We're going to pipe it in to go ahead and load some data into the Redis database, because we just stood up Redis, but we didn't put anything in it yet. So let's go ahead and do that. I'm in this state directory. I'm just going to make sure again, if I cat states.txt, you can see kind of what the Redis commands look like. And if I just pipe it, it's Redis CLI pipe, it's going to tell me that all data was transferred, 0 errors, 50 replies. We loaded 50 states in there. Each of them is a hash set with a called states with a abbreviation and a name. And now, if I go into my page, I had 11 visits. On the 12th visit, what do you know? Abbreviations and states. Okay, and all this is, and you can look at the directory if you're really interested in how the PHP works. But if I was to do less on index.php, we have the US states. We have some PHP code that connects to a Redis box, a box called Redis. It's actually the DNS name of it. It grabs a number of visits. It grabs a hash of all the states. And once it has it, it uses PHP, and this is some simple PHP. Print out the value of visits, print out the abbreviation and name for each of the states you get, right? I don't want to get into PHP too much, but that's all this is doing, right? And so we get this states view here, and 12 visits, 13 visits, right? Index is incrementing each time, right? And that's actually, where's the increment? Oh, right here. Redis, increment the number of visits. That's why it's doing that. Okay, so I loaded some data into Redis, right? Bulk. I could also do it interactively if I wanted to, if you just want to see a little bit about Redis. Sorry, that was a little bit quick, but you'll see the commands here. Redis CLI. It connects to localhost 6379. So I'm on my workstation here, but of course 6379 on my workstation maps to 6379 on the Redis container, because we did that port mapping. And now I could just type in, you notice as you type in the Redis CLI, it gives you some hints. The key field value, the key is states. Let's go ahead and put in an entry for Puerto Rico. Right, oops, I put a misquote. There we go. So it went ahead and added it. Let's also go ahead and set the visits variable. I'm going to go ahead and make myself much more popular. Rather than 13 or 14 visits, now I've had 1,234. I can go ahead and exit out of this. I can switch back and reload. And sure enough, we've had a lot more visits, and Puerto Rico's in the list. Okay, so that was some simple Redis. Redis is a great tool. It's very easy to use, but you can see now we're actually using a dynamic website that we've mapped together. Well, how is all this working, right? There's got to be something to it. And we'll show how it all works together in a map a little bit later. But one of the things we need to do is be able to test something. We stood up a whole environment here, but we want to be able to test it. So let's do something even more impressive. We've got 3 containers still running. Let's go ahead and add a Selenium grid. And this is, for testers out there, hopefully people are familiar at least with what Selenium is. It's remote control for a browser. It's browser automation software. It's free. It's open source. It works for a lot of different types of browsers. It also works in a lot of different languages that you can write the code. So I'm going to go ahead and stand up a Selenium grid. okay? I'm not just going to use Selenium on one box. I'm going to stand up a grid that has Firefox and Chrome as options for me. And I'm going to do it using that Docker Compose, the same Docker Compose command we used before, just in a different directory. So if I go ahead in here into states, I'm going to go ahead to switch to the states Selenium directory, which we've seen before. If I look at what's here, there's a Docker Compose. And if I actually, let's go ahead and look at that Docker Compose real quick. I see version 3 we saw before. I got services. I have a Firefox service, a Chrome service, and a hub service. The hub is actually going to act as our mediator. The image is I want version 3.141.59 of Selenium Hub, right? That particular image. Ports 4444 is where the hub console is. So I'm going to map that, expose that. I'm going to stand up Chrome, and I'm going to stand up Firefox. They each have their own images, but I want to pick the same matching version here. I'm going to map this volume so it can share memory between them. That's just something you need to do on this. I say that this depends on, and this depends on my Chrome and my Firefox volumes depend on Hub being up first. So this just tells it, hey, even though they're listed first, stand up Hub, and it's going to need to know that Hub is there. It's also going to need to know that where the Hub host is, right? This environment variable Hub host is something that the Firefox container and the Chrome container need, and they need to know the name of the hub. Well, because I didn't do anything special, the Docker Compose is going to call this DNS-wise hub. All right. So I'm going to go ahead and I'm going to start these up just with Docker Compose up-d again, right? So now I will have 6 boxes up and running, and you'll see it's pulling a bunch of things for the hub. You'll also notice here creating network Selenium default, a different network. All right. Now, so it's creating a different network than I was using before. This is not on the same network as my Nginx, my Redis, and my PHP. Also, you see when it went to pull down Chrome, a lot of those layers for Firefox were already known. A lot of the layers for Chrome were already known. Why? Well, because they're the same ones that we loaded for Selenium Hub. The basis of Selenium is the same between them. So those are already shared, not only on disk, not only don't I have to download them again, but literally they're not taking up any more space in memory. Okay, so I have these 3 up, just a few layers different between them. When it's done, I see it created these 3 new images. A Docker PS shows that I have 6 images running, right? I can see that it created this new network, Selenium default, right? And then I can go ahead and look at the Selenium Hub in my browser by going to port 4444 grid console on my directory. So let's go ahead and do that. I'll go ahead and pop that up. And I see on 4444 grid console, I see my Selenium grid console that shows that I have a Firefox browser, a container with a Firefox browser running here, right? It's this IP address on that network. I can't access that network because it's blocked off for me, and this Chrome browser. So Firefox 75, Chrome 81.0, right? Fairly recent. I have those running. I can actually click through. This is just the Selenium grid. You can see some more information about them if you really wanted to. Not much there. But the big thing now is I have 6 containers up and running on this T3A small image that I gave you guys, all sharing 2 separate networks, completely blocked off from each other. If I go back in, take a look, we already went through what the Docker Compose looked like for Selenium. The big thing was that the hub name shows up here and here. All right. Now I want to use that. So I have all this running. How do I access Selenium grid? Well, I write a Selenium test. I don't want to make this a tutorial on Selenium, but we have to run it. I've written these in Java. You can go ahead and see this next command if you want by looking at this gist. But the key here is I'm going to stand up a Docker container that's not going to stand around for long, but we don't have Java or Maven installed on our host, on our workstation, right? So I'm going to have to do that using a container that does have them. I'm going to use a container called Maven 362 JDK12. It's a Maven container. It has Apache Maven installed and a JDK version 12. And I'm going to do some familiar stuff, some non-familiar stuff. I'm going to put it on a network. I'll walk through it in a second. Let's go ahead and do it because it's going to have to compile some stuff. And I'll talk about what it does as it runs. One thing really important to notice, this network Selenium default. Okay, so that's a key. Let's go ahead and run it. Docker run -it. I want it to interact with it. I want to see what's going on as it's running. I want to remove it when it's done. I don't want to, this is ephemeral. I'm going to compile, I'm going to run tests, I'm going to blow the container away. I don't need it anymore, so I'm not going to keep it. I am going to call it Maven so I know what it is. The line is long. Let's go ahead and split this up. Rather than typing in my path, I can use this little trick, just a shell trick, a bash shell trick actually, to say get the results of whatever my current directory is. And I'm going to use that current directory, which happens to be the state Selenium. I'm going to map that to user source Maven on the Maven container. Turns out if I was to read the Docker hub on that, I'd see that that's where the Maven container expects our source code to be. So it's in my current directory, or actually my POM file expects to be there. I'm going to do this other map. I'm going to say I want to take my home directory, and this is my local home, the home on my workstation. I'm going to make one called m2.m2, and I'm going to map that to the m2 on the container. We saw that when we ran something with Maven earlier, it downloaded a lot of stuff. Well, but it downloads it to the container. And so when the container is blown away, because we're going to blow this away as soon as it's finished, I want that to be kept around because I don't want to have to download those packages, those jar files, those dependencies every time. So I'm going to map those locally. I'm going to say my work directory is user source Maven, right, which I just mapped to my current directory. I'm going to go ahead and use the network Selenium default, which I just stood up with my Selenium. So this box that's going to run is on the same network as Selenium, as the Selenium grid is. I'm going to run the image Maven 362-JDK-12, and I'm going to do a Maven. The command I'm going to run is Maven clean test, and I'm going to pass it a test URL in a variable. Test URL equals HTTP my IP address, which I need to look up because I've been cheating and had it pre-typed. There we go. Oops. Forgot I would have that already. All right. So I'm going to point to my workstation. I'm going to tell it, I'm going to send that to the test. And I'm going to run this. And we're going to watch it run. You'll see it twice, so don't worry about if you miss stuff the first time. It's going to have to download the Maven image locally. We see this one's fairly big. It downloaded it. It's going to go ahead and do the Maven build, and it's going to download, like I said, download the internet. But this time, rather than writing those files out to the container, we mapped it to something on my workstation so I could actually store that stuff. So I'm caching it locally, right? Once all that's done, it's going to run some tests. The states test and test passed. And we can take a look at that states test. Let's see what's in this directory here. We got the POM file, but if I actually look at our source test Java way down there. It's the source directory test Java. That's a Maven convention. The class name is Coveros tutorial functional tests. Coveros tutorial functional tests, and the file is states.java. This is a Java class that's made to run a Selenium test. Again, not going to make this a Selenium course, but we see a couple things that are familiar. We passed in a test URL, and that's where it got it. We have a hub URL, which is hard-coded because we know it's going to be called hub. And then it just does it says it's going to take a Chrome browser, and it's going to check to see that we have US states as the title, that Wyoming's in the list, that if I find the WY abbreviation, that's some XPath, the text for that next box will be Wyoming, right? If I find the row I find the table row with the table data of WY, then the second column will say Wyoming. That's all that's saying, and that the title is abbreviation, right? So that ran. So let me go ahead and run that whole command again. You see it's all on one line. I can just use up arrow to get back to it. I'm going to rerun it. This one will go a lot quicker, and it'll be easier to see what's going on because it actually doesn't have to download all of that. We cached it all, and we see it's all running. Great, it passed. Now, if I wanted to go in and change that, I'm going to go ahead and use nano again. You don't have to do this, but I can go ahead down and change. I'm going to get rid of, comment out the Chrome, and I'm going to use the Firefox. I'm going to say, yes, save it, and then run that command again. And it's going to compile the test this time again. But it's going to run it, and this time we see it's running Firefox, right? And so what it's actually doing is it's going out and hitting the Firefox part, or it's hitting the hub and asking for a Firefox browser, and then running the test right there. Okay, and you see it passed again. Now, let's take a look at what we really saw there, okay? Because I know this is complicated. I'm moving fairly quick through the Selenium part, but the network piece is the important piece. We stood up a network called states default, right? We had www, PHP, and Redis. Redis is our database. We exposed port 6379. PHP was running the FPM version, opens up port 9000 to www. The configuration we had here for www said, hey, if you get anything that ends in PHP, send it over to port 9000 to the PHP. And let PHP handle it so it's dynamic, right? And we were accessing it all from the internet on port 80, right? That's step one. Then we stood up a whole separate network that doesn't talk to this, that just had a hub, Chrome, and Firefox. And they were both running on different IP addresses, both on port 555. The hub, we saw the grid was running on port 4444, right? And then we went ahead and stood up another box in it, Maven, right, that was in that same network, right, and we told it to talk over port 4444 to the hub, right, and when that command ran, we actually, by giving it the test URL, we told Chrome first, and the second time we ran it, we told Firefox to go out to the internet over port 80 to the URL, which was our IP address, and so it came in through the workstation. And because we've exposed port 80 on states default, it went ahead and hit this and kicked off the whole rest of the stuff. So it was actually accessing it. Now, one of the important things to know is that Docker named all those containers. We didn't need to tell it the IP address of all those systems that got stood up because in the Selenium code, we said the hub URL was hub, right? That was the domain name. So, and we named that in the Docker compose, right? We told it that those depended on the hub, and then we passed around the host, the hub hub host as hub, and then actually in Nginx we actually the fast CGI, that was the FPM piece. we pointed to PHP 9000, which is our in our site conf, so that it had access. And then actually in the dynamic web page in our index.php rather, we connected to the box Redis. All these in red, these were names that Docker Compose took care for us, right? It named it in its networks. It has its own DNS system that we could refer to, so we don't need to know where these pieces are, right? So you can go ahead and play with this. You can change the test. You can do some other stuff with it. You can even add some other systems. So one of the things you may have noticed on it is, oops, went too far. One of the things you may have noticed on this, when I stood up Selenium grid, let's do that Docker up again. Tell me they're all up to date, right? Docker, the Selenium Hub, Firefox, and Chrome. I can actually go ahead and do this. Let's see if I remember the command. What I told it to do was to say, I want to stand up the Docker Compose, but I want to scale the boxes that said Chrome. Give me 2 of those, right? Not just one, give me 2 of them. And you see now that what I have here, if I just do the Docker up again, oh, I need to scale 2 there. If I do the Docker PS, I'll see that I actually have 2 Chromes up and running, Selenium Chrome 2 and Selenium Chrome 1, right? It picked the names for me. And now if I go back to my grid console and reload, I've got 2 nodes here, right? That's all it took. I didn't even need to change my Docker Compose to do that. I just said I wanted 2 of them, right? And now I could go ahead and again, I could rerun that command. Ooh, let's go ahead actually change my test again, since I should have doubled Firefox, but not that it will matter. I'm still only going to run 1. I'm going to rerun this. It's going to recompile it because I made a change. But now if I actually had another window open and reran that command at the same time, the hub could actually use a second copy of Chrome. So in this way, if I had a big enough box, this box isn't really big enough to run too many of those more, right? We're already running at any given time now 7, 8 different images. The Nginx, Redis, PHP. We're running Selenium Hub, Chrome, Chrome 2, Firefox, right? So there's 8, and then actually we're running the 9th with Maven. I didn't do that right. 3, 6, 7 is Chrome 2, and then 8 is there's 7 rather is the Maven. Sorry about that. So Maven's running ephemerally, right? It's deleting itself as soon as it's done and removing itself as soon as it's done. But if you had a bigger box that is running this Selenium grid, you could have all different combinations. You could have a Chrome 81, a Chrome 82, a Chrome 83. You could have several of those available. You could have a couple different versions of Firefox, the current, let's say, in the last 2 maybe. I could have a Windows box running somewhere. Unfortunately, Windows boxes can't be Dockerized, but I could have a Windows box running somewhere that had IE running, so that I could point to it as well. And then I could just hit the hub, hit the hub and ran a bunch of them in parallel, or a bunch of people running them in parallel, and the hub would handle hitting all of those. I wouldn't need to worry about standing up all different versions, and I just use this desired capabilities that you see pop up on the screen and in the test to do it. So again, this is not a Selenium class, but you can see where all this would play in. It would be really helpful. All right, so one last thing, we want to go ahead and clean up, and we're going to do that with the Docker Compose stop. We did a Docker Compose up. Sure enough, Docker Compose stop will do it as well, and we want to remove them when they're done. We're going to have to do this twice, right? Because we want to do a Docker compose stop here. Stop those four. I'm going to go back to the states directory and do a Docker compose stop to stop those. And if I really wanted to, I can, in here, I could do the remove, shut them down. I can go back into Selenium. I can get rid of those containers, knock them out, right? So they're removed. That's just like the Docker stop and the Docker remove command. And it's all closed up, right? And now I can get rid of this box when I'm done. And that's everything. So, yep, that's all the pieces to remove it and clean up after we're done. So thank you very much. If you have any questions for me, I am available on the TechWell Hub. If you're not already a member of the TechWell Hub, go ahead and look at that QR code or go to hubtechwell.com. If you put in your email address, you'll get an email back inviting you to our Slack channel. And Docker Hub, at the time I'm speaking here, has about over 5,000 members, testers, developers, DevOps people. I happen to hang out a lot in the DevOps channel. If you have any questions for me, I'm at Gene Gotimer in DevOps, and I hope you enjoyed this. Thank you very much.